So, hello everyone again. Finally, this may be the end lecture, lecture 7 part 3 of electromagnetic induction. I am Sameer Lavankar. So, let us begin our discussion. So, for the last time, this is the course outline. We started with the definition of electromagnetic induction. What is electromagnetic induction? What are the applications of electromagnetic induction? Who started this electromagnetic induction? We learnt about two scientists, Oersted and Henry. Their inventions which led to the discovery of AC generators, transformers, etc. Then next lesson we studied about the experiments of Faraday and Henry. There were 3 experiments to be very precise: experiment number 1, experiment number 2, experiment number 3. Experiment 1 involved a coil C1 with a bar magnet M. Let me denote the bar magnet by capital M. Then the experiment number 2 had 2 coils, that is C1 and C2, C1 and C2, and then experiment number 3 had again 2 coils, coil C1 and coil C2, but this time there was a tapping key involved. There was a tapping key K involved for the completion of the circuit in coil 2. The procedure was similar. If the bar magnet is held constant and coil C1 is moving away or towards, if the coil C1 is held constant, then bar magnet M is moving towards or away from the coil, and similarly in experiment 2 and experiment 3. Then next was magnetic flux. It was nothing but the definition or the inculcation of the formula phi b is equal to B dot A, which is equal to B A cos theta, B A cos theta, where cos theta is the angle between B and A, vector of B and A. Then next was Faraday's law of induction, that is epsilon is equal to minus n d phi B by dt. Next was Lenz's law and conservation of energy, in which we understood the concept of conservation, how the energy is changed from one form to another. Energy can neither be created nor be destroyed. Next was motion electromotive force, in which we learned this new formula which was BLV, where V is the velocity of the conductor moving inside or outside. The next was inductance. Inductance were of two types, self and mutual inductance, and finally the applications of everything was put into the last thing, that is AC generators. Then we were calculating the value of epsilon produced in AC generator. It was equal to NBA omega sin omega t. Hence, the maximum value or the extremum value of voltage produced is NBA omega, and it is a sinusoidal wave. So, it can be maximum, it can decrease, it can increase, and hence because it is a sinusoidal wave, it has an alternating effect. Sometimes it is positive, sometimes it is negative. Hence, the current produced in this case is known as alternating current. So, now this is the course outline. The complete chapter is completed. In this lecture we will be going through some of the problems associated with every concept we studied in this lecture. So, let us move on to the problems. So, on the right hand side you have the formulas written here. This is the complete formula list of every concept being taught in electromagnetic induction. You can memorize it and then you are good to go. So, let us move on to the first problem here. So, a rectangular wire loop of sides 8 centimeter and 2 centimeter, that means the area is given to you, the length is given to you as 8 centimeter and the breadth is given to you as 2 centimeter. A rectangular wire loop of sides 8 centimeter and 2 centimeter. Please make sure to standardize the units everywhere. You need to convert centimeters to meters here. That means it will be divided by 100 to convert it into meter, and this also by 100 to convert it into meter. With a small cut is moving out of a region of uniform magnetic field of magnitude 0.3 Tesla, that means the value of B is given to you, directed normal to the loop. What is the EMF? EMF as in you need to find out the voltage or the epsilon value here, developed across the cut if the velocity of the loop is 1 centimeter per second. So, all in all, if I understand it from the problem here, it is a question of motional electromotive force. So, somewhere or the other the concept epsilon is equal to BLV has to be used in the problem. Moving on. So, velocity of the loop is 1 centimeter per second in a direction normal to the, so there are two questions here, one through the longer side and one through the shorter side. So, for how long does the induced voltage last in each case? So, we need to calculate two things. First of all, we need to calculate the EMF value and then we need to calculate the time value. So, let us look over the solution here. Everything is written very clearly. So, now please listen here. So, length is given to you, breadth is given to you, hence area is given to you, that is length into breadth. B is given to you, velocity is given to you. we need to convert everything into standard units, that is in meters and meter per second. So, after converting, let us look over to the first problem here. So, EMF developed in the loop is given as epsilon is equal to BLV, the same formula written here for a quick reference, which is equal to B is given to, already given to you here, length is already given to you because it is given that it is along the normal side, sorry, it is along the longer side. Therefore, L has to be used here and velocity is given to you. Calculating it mathematically gives you the value of voltage as 2.4 into 10 to the power minus 4 volts. Now, time is nothing but we know that speed is equal to distance upon time, speed is equal to distance upon time. So, direct use of this concept is being used here, and hence we got T is equal to, please make sure here B is being used, here B is being used, not L is used. Therefore, T is equal to small b upon V, and that is 2 seconds. So, for 2 seconds this induced voltage has been lasted in the first case. Moving to the second case, EMF developed here will be again BLV, but this times L value, the length value will be of shorter side because shorter side is being asked. Therefore, B into small b into small v, everything is given to you in the question. Just mathematically we get the value as 0.6 into 10 to the power minus 4 volts. Again T is equal to here, sorry, this should not be B this time, it should be L this time. So, it is small t is equal to small l upon V, that makes it 0.08 upon 0.01, which is equal to 8 seconds. So, please make sure that the time, in the time the distance or displacement which is asked should be of the other side, it should be of other side because the other side is which is moving, that is why we need to calculate the value of time with respect to that. Therefore, T is equal to small b upon small v, which is equal to 8 seconds. So, you can see for both the side the time for which the induced voltage is being kept is different. So, this was the concept I need to make you understand in this, that time will be changed if the longer side or shorter side of the loop is being varied. Hence, the induced voltage is 0.6 into 10 to the power minus 4 volt, which lasts for 8 seconds. So, this was this problem. Let us move on to the next problem here. So, a 1 meter long metallic rod. So, 1 meter long metallic rod is being used. Let me iterate it by a diagram. So, 1 meter long metallic rod is rotated with an angular frequency of 400 radians per second. If radians is given to you, then it is quite evident that the omega value is directly given to you as 400 radians per second. Just in case if it was written as 400 revolutions per second, that means the value of frequency is given to you. Frequency can be denoted by either small f or by nu. This is known as nu. So, if this is given, then omega can be directly calculated as 2 pi f or 2 pi nu. So, again reiterating the problem here, a 1 meter long metallic rod is rotated with an angular frequency of 400 radians per second about an axis normal to the rod passing through its one end. There is a normal and this is the axis here given to you. The other end of the rod is in contact with a circular metallic ring. So, this is rotated, this is in with a circular metallic ring is attached here, circular metallic ring. Let me write it in short form because the area is constrained to me. So, with a circular metallic ring, a constant and uniform magnetic field of 0.5 Tesla. So, capital B is given to you, parallel to the axis exists everywhere. So, everywhere it is constant, that means there is no change in B. So, you do not need to change the value of B with respect to area, only so the last line just tells you that you need to take capital B value constant everywhere. So, calculate the EMF developed between the center and the ring. So, this was, let us say this is the center and this is the ring. So, you need to calculate the EMF outside. So, again directly as the value of B is constant and there is a change in the V value, therefore, there is something therefore, the concept again is of motional electromotive force. Motional electromotive force is B into L into dV. B into L into V, sorry, not dV, B into L into V. Or if you are talking about a circular metallic ring, then it will be equal to B into L square into omega by 2, B omega L square by 2 or B omega L square by 2, which we derived in the subsequent slides of motional electromotive force. So, solution, so length is given to you, omega is given to you, B is given to you. So, directly EMF developed will be nothing but B omega L square by 2. This was the same formula when we calculated. I will just iterate to you again. So, let us say this was the magnetic field, just to make you remember. This was the magnetic field, there was the center, there was a long rod and there was a metallic ring going in this direction. So, when it was going in this direction, there is a change in theta, and because of change in theta we need to calculate the value of epsilon here, and the epsilon which we calculated in that lecture was b omega L square by 2. So, same formula is being used here, nothing has been derived new, just you need to remember this formula and you are good to go. Please make sure that, but only make sure that BLV can't be used here, b omega L square by 2 has to be used, because the rotation, because the rotational effect is been inculcated here. There is not a straight line, there is a no straight line movement. Let us say if this is the conductor, and let us say the area is being moving, if the area is being contracting. So, this is not a simple case, it's a case in which the value of the velocity is in this direction, because the velocity is this direction, because it is rotating in a rotational form, that is why the formula will differ. So, finally calculating it mathematically, we get epsilon value is 100 volts. Moving on to the next problem, a horizontal straight wire 10 meter long. So, a straight wire is given to you, the length is given to you as 10 meters here. So, a horizontal straight wire 10 meters long extending from east to west is falling with a speed of 5 meters per second. So, the speed is given to you. So, the speed is given to you, that means the velocity v is given to you as 5 meter per second. Next, at right angles to the horizontal component of Earth's magnetic field. That means, if I take you a simple case, let us say, okay, I will make you like this only. So, it is something like this is moving downwards and this is the magnetic field going, something like this scenario is coming. So, if you take this case and you will shift it like this, and it is a simple case, same case again of motional electromotive force, in which the velocity is going like this and there is a change in the induced, there is a change in the epsilon, that is epsilon produced. What is epsilon? Epsilon is voltage produced, EMF produced. So, now horizontal component of Earth's magnetic field, so B value is given to you. So, now first question asks is what is the instantaneous value of EMF induced in the wire. First question is epsilon value you need to find. Second is what is the direction of EMF, and third question is which end of the wire is at the highest electric potential. So, let us look over the solution here. So, first of all, EMF induced in the wire is epsilon is equal to BLV. As I already told you, if you shift it like this and then let us say this wire is moving inside, then there is a change, in the area. Because of change in area, there is a change in the flux, and because of change in flux, there is a EMF produced. Which EMF is produced here? It is a motional EMF produced, hence it is the value of epsilon, which is voltage. So, EMF is nothing but BLV, BLV is the same formula written here towards your right. So, just simple mathematical putting of B, L and V gives you the value of EMF as 1.5 into 10 to the power minus 3 volts, or in millivolts it is 1.5 millivolts. Next, it can be inferred that the direction of the induced EMF is from west to east using Fleming's right hand rule. So, Fleming's right hand rule may be taught to you in the previous lectures. It is nothing but if the motion is towards your thumb, if the current is going like this, then the magnetic field is like this, or it can be any ways. If two values are given to you, then you can find the direction of the third value. Let us say the current is given to you, that the current is moving in this direction, if the field is moving in this direction. So, if you take like this, if you take the case like this, then you will get that the value of the induced EMF is from west to east. You can try it by yourself also. If you try it from yourself, you will get the value of direction as west to east, like this. Maybe because of mirror change you will find it different, but if you find it by your hand only, you can find that the value is going from west to east. It is a simple question only, not typical. Next, the east, so which end of the wire is at the higher electric potential? The eastern end of the wire is at the higher electric potential. Simple case only. So, the value of maximum, so that because of this case only there is a change, because the direction is from west to east, so east value will be higher, maybe the mirror case might come here, the east value will be higher and the west value will be lower. Next question. So, now current in a circuit falls from 5 to 0 in 0.1 seconds. So, looking from the first line here, there is something inferring about di by dt. If something is inferring about di by dt, I think this question can be of self inductance or EMF produced, because we already know for value of EMF produced by change in current, it is minus L di by dt. So, sometimes by looking at the question, you need to understand in your brain that which type of question may be asked to you. So, from the first line it may be that if the di by dt is being questioned here, that means it is about it is about EMF reduced. Current in a circuit falls from 5 to 0 amperes in 0.1 second. So, dt is given to you, di is given to you. If an average EMF of 200 volts is induced, so epsilon value is also given to you, give an estimate of self inductance. So, see, it was a question of self inductance only, in which the value of capital L was asked to you. Okay. So, now moving to the solution here. So, solution initial current was given to you as 5, final current was given to you as 0 amperes. So, therefore, change in current is nothing but final minus initial, that is I2 minus I1, which is 0 minus 5, which is minus 5. Why I wrote this? Because you need to understand that the change in current was negative, the change in current was not positive. So, change in current is minus 5 amperes, time is given to you as 0.1 seconds here, average EMF epsilon value is also given to you. So, now directly just using this formula might be written here also, see. So, epsilon is equal to minus L di by dt. So, directly just value putting of epsilon, di and dt, you will get the value of L as 4 henries. H is Henry here, H is Henry here. So, hence the self inductance of the coil is 4 henries. Moving on to the next problem. So, a pair of adjacent coils has a mutual inductance of 1.5 Henry. So, the capital M value is given to you as 1.5 Henry. If the current in one coil changes from 0 to 20 amperes, that means di is given to you and dt is also given to you. So, that means di by dt is given to you, di by dt is given to you. Then what is the change of flux linkage with the other coil? That means value of n phi is asked, if I am not wrong, or either the value of n phi is only asked to you, n phi, or because n value is all understood 1, if the question is not given, that means the value of phi is asked to you. Either from this case epsilon value can also be asked to you, a different question scenario I just put up in front of you. So, now let us look over the solution here. So, mutual inductance of a pair of coil is 1.5 Henry, I1 is given to you, I2 is given to you, that means final minus initial is 20 amperes, it is positive value this time. dt is given to you as 0.5 seconds. So, directly using this formula, we know this formula from here, it is minus d phi b by dt, and we know this formula from here. If it is a case of mutual inductance, then capital L will change into capital M. Now, as epsilon value is same, then means using equation 1 and equation 2 we can equate both the equations and we can write it as minus d phi by dt is equal to minus m di by dt. And now, in this case dt is known to you, di is known to you, capital M is known to you, you just need to calculate d phi, and that is the question here. So, mathematically calculating it, dt can also be cancelled here. So, even if this 0.5 second was not given to you, there is no hesitation while solving this problem. So, minus m, so 1.5 is given to you and di is given to you, that means phi b is 30 Webers. The unit of magnetic flux is nothing but Weber. So, hence the change in the flux linkage is, the change in flux linkage is 30 Webers. Moving to the final problem of the entire discussion of electromagnetic induction. So, a jet plane is travelling towards west, a jet plane is travelling towards west at a speed of 1800 kilometers per hour. So, velocity is given to you as 1800 kilometers per hour, you need to change it into meters per second, that is you need to multiply it by 5 by 18 meter per second. What is the voltage difference developed between the ends? So, voltage difference is being asked, that means epsilon value is asked, and if velocity is given to you, that means in and all it is a question again of motional electromotive force. So, voltage developed between the ends of the wing having a span of 25 meters. If the span is given to you, if I make a typical example of a aeroplane, that means the span, this value is given to you as length, which is equal to 25 meter. So, nothing, the movement is like this is the movement, if I show it like this, the movement is like this, and hence there is a EMF produced. Having a span of 25 meters, if the earth's magnetic field at the location has a magnitude of B. So, B value is also given to you as 5 into 10 to the power minus 4 Tesla, and the dip angle is given to you. What is the use of dip angle? The dip angle has a use only to find out the exact value of B acting at it. So, the value of B acting, which we will use in formula, let us say I write it as B dash, is B sin delta. We use a dip angle as delta value, this delta, small delta. So, given V is given to you, L is given to you, B is given to you. Please make sure you need to convert kilometer per hour into meter per second. So now vertical component of Earth's magnetic field is nothing but BV sin delta, because this time we need to calculate the value of vertical component. We don't need horizontal component. Horizontal component is in line with the movement of the plane. So that's why we need to calculate the magnetic field like this, and then we will need to calculate the motional EMF produced. So BV is equal to B sin delta, that is equal to 2.5 10 to the power minus 4 Tesla. Voltage difference is nothing but directly use of this formula, that is equal to BLV. Hence we get B is given to you, L is given to you, and velocity is given to you. Directly using all the mathematical terms, we get the value of EMF produced is 3.125 volts. Hence the voltage difference developed between the ends of the wings is 3.125 volts. Hence this is the final lecture series on electromagnetic induction. I thank you all for listening patiently everything. In this lecture, just a literal summary. So AC generator problems were being told in the starting, and then finally I explained you some of the NCERT books back problems. So thank you for bearing with me. This is the course progress review, everything is completed. So introduction is done, Faraday's law of Faraday and experiments of Faraday and Henry are being done, magnetic flux is done, introduction, Faraday's law of induction is done, Lenz's law and conservation of energy is done, motional electromotive force is done, inductance is done, generators is done, and entire problems are being told to you. So for now, thank you. May meet you soon.